So in this video, we're going to learn how to find the area of a figure that's graphed on a coordinate plane, like my triangle ABC here. So if you have a piece of graph paper, you might want to graph these 3 points as well. So if we're going to determine the area of the triangle, let's think about what we need. We just realized that the formula for the area of a triangle is area equals 1/2 base times height. So if I think about this, maybe side BC will be my base, and then I'm going to need an altitude for my height. I'm going to need to draw something in here that makes like a perpendicular. And then I can find the length of the base and the length of, I don't know, if we call this maybe like point D here or something like that. Oh, but that's a problem. Because yeah, I can find the length of BC. I can find that distance there. And I can find the length of AD once I find the coordinates of D. And I don't really know offhand what the coordinates of point D are. So I'm going to have to do some algebra and some equations of lines to do that. So let's play with that a little bit here. So first, if we're going to find the length of point BC, and again, B was at -6, -4, and C was at 4, 1. So the distance between them then, I'm going to do my distance formula. Take my big old square root, and I'll do -6 minus 4 squared, difference of the x's. And then we'll also take the difference of the y's. We'll go -4 minus 1. So let's see, -6 minus 4 is -10. And we square that and we get 100. And then -5 here, and we square that. So this distance then is 100 plus 25, or the square root of 125. Okay. Now again, I can't really find the length of the other segment AD that I'm looking for. If I go back for a second, I can't find the length of AD because I don't know the coordinates of point D. So what I'm thinking about doing is I'm going to write the equation of the line containing BC, write the equation of the line perpendicular to BC that goes through point A, and then I can find their intersection using some algebra. I think that's the plan I want to do. So let's see, let's find for the equation of BC, I got 2 points on it. Let's find the slope of BC. So to find the slope of BC, I'm going to do the change in y over change in x. -4 minus 1 over -6 minus 4. And that's what? -5 over -10, or a positive 1/2. And then if I use my point slope form of a line, maybe the equation of a line is going to be, let's see, y equals the slope. And maybe I'll use the point 4, 1 in this case. So I'll say x minus 4 plus 1. So that's the equation of the line that contains BC. Now, in order to find point D, I want to make it so that AD is perpendicular to BC. So therefore, I want the slope of line AD to be positive or -2 because it's its opposite reciprocal. And then if I use point A, I can write the equation of the line. But notice, point A was the y-intercept. So I can actually write this in y equals mx plus b form. So the equation of this line then is going to be y equals -2x plus 4. Now these two lines here, I want to find where they intersect. Because if I can find where they intersect, that's my point D. So let's go and do that. Let's see, I need a little bit more room here. So in order to find the coordinates of AD, let's set those two equations equal to each other. So I'll take the first one, which was 1/2 times x minus 4 plus 1, and that's going to equal the length of, or the equation for AD, which is -2x plus 4. Solving that for x, let's see, maybe we'll distribute. We'll get 1/2 x minus 2 plus 1 equals -2x plus 4. If I solve that equation, let's see, -2 plus 1 is a -1. Let's add the 2x to the other side. We'll add 1 to the other side. On the right, 4 plus 1 is 5. 1/2 plus 2 is going to be 5/2. And if I multiply by its reciprocal, 2 over 5, I'm going to get x equals 2. Now let's go back and plug in x equals 2 for one of the points. Maybe I'll take the line AD. Y equals negative 2 times 2 plus 4. Oh, look at this. We get y equals 0. So then the coordinates of point D, it was at 2 comma 0. So let's go back and make that picture a little bit better then. So here is point D then. Yeah, that looks a little more perpendicular than just my sketch was. So now we can find the distance of segment AD. We can find its length. So the length of AD, we're going from 0, 4 down to 2, 0. So if we do another distance formula, let's do 0 minus 4 squared and 2 minus 0 squared. So I'm going to get 0 minus 4, negative 4 squared is 16, and 2 squared is 4. So the length of AD then is radical 20. Okay, so I knew the length of my base from before was radical 125. I know the length of my height, my altitude, is radical 20. So then to find the area, let's see, we got to do 1/2 of the base times the height. And if I can multiply my radicals together, I multiply the 125 by 20, and 125 times 2 is 250. So times 20 is going to be 2,500. Ooh, that's nice, because I know what the square root of 2,500 is. The square root of 2,500 is 50. So the area of this is going to be 1/2 of 50, or 25. Nice. Whew, a lot of work. But wait a minute, what are those little dots on the bottom right of the screen? Oh, that's right, or we could box the area in. What? Let me show you what I mean by that. So here's my figure, triangle ABC. Let's box it in. What I mean by that is, let's put a box around it. Go ahead, draw a box around yours too. Because with this box now, I know that the lengths of the sides are just horizontals and verticals. So it looks like if I count from point B straight up, 1, 2, 3, 4, 5, 6, 7, 8, its height is 8. And if I go across the bottom or the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then what I have now is the area of my box is 10 times 8, which is 80. Now what I then have is 3 other regions that I'm going to kind of remove. Call this region region number 1, call this one 2, call this one 3. So if I subtract the areas of these 3 pieces from my box, I should get my leftover area, the area of triangle ABC. So the area of part 1, it's a triangle. I know one side is 8, the other side is 1, 2, 3, 4, 5, 6. So it's 1/2 of 8 times 6, and that's 24. You find the area of regions 2 and 3. Region 2. Let's see, it looks like it's a 4 by 3. So that area is 6. Area 3, it's 10 across the bottom. It looks like 1, 2, 3, 4, 5 up the top. And let's see, that's going to be 25. So then the sum of these areas, 25 plus 30 is 55. So then if I want the area of ABC, I'm going to do my total area minus the sum, and look what I get, 25. Yeah, which one do you like better? I like shading, I like the boxing it in. That's much better for me. Alrighty, you get to practice one now. Determine the area of this quadrilateral, whose vertices are given as A, B, C, and D. Give it a shot. So point A is down there. Nope. That's -1, +1. Point A is down here at -1, -1. B is at -1, 7. Looks like it's up here. C is at 1, 8. It's up there. And D is at 7, 3. So here's A, here's B, here's C, and here's D. Let's do the old box it in, box it in. Notice that A and B make a vertical, so that's pretty cool. And what I probably should have drawn was my figure originally. So let's see the area of the box. It looks like it's a total of 9 by 8, is that? 9 by 8? So the area of the box is 72. I got 3 regions here. Do you always have 3? No, not always. You have as many as you need. So put the area of region 1. Looks like it's 1/2 of 8 by 4. 1, 2, 3, 4. So that area is 16. Region number 2, it looks like it's 1, 2, 3, 4, 5, 6 across by 1, 2, 3, 4, 5 down. So 1/2 times 6 times 5, that's going to be 15. And the area of that little tiny region 3, it's not 1/3, it's 1/2. Looks like it's a 1 by 2, so that area is 1. If I sum these areas, their sum is 32. So then the area of quadrilateral ABCD is 72 minus 32, which is 40. Woo! Finding the area, if you want to do it the long way, you can. I'd prefer if you box it in. I think that would be nice.